So let's talk about how we can connect a declarative agent to an MCP server, but with security in place via open authorization. So I'm Paolo, I work for Microsoft as a senior developer advocate. And today, first of all, just to give you a very quick bit of a context, MCP stands for Model Context Protocol. We use it to plug into our AI systems, mainly agents, additional capabilities and functionalities like we do whenever we plug some devices into our smartphones or tablets or PC using a USB-C port. The MCP protocol is really powerful because it allows you to enrich your AI systems without the need to create actual code or creating or developing solutions to achieve your goals. You simply need to connect to an MCP server. The MCP client will be able to list all of the tools made available by the MCP server, and based on the orchestrator and on the prompt of the user, you will be able to rely on the tools you actually need to accomplish the task and to complete the prompt you provided to the agent itself. So it saves time for developers and it gives a better user experience to the end users. From an architectural perspective, whenever you have an MCP server, the MCP server provides tools, resources, and prompts. Tools are like functions or functionalities. Resources are actual data that you can provide, and the prompts are prompts working on top of the tools and resources provided by the MCP server. You can have as many MCP servers as you like, and on the other side of the architecture, you have an MCP host, which could be, for example, Microsoft 365 Copilot, but can also be GitHub Copilot or any other IDE-based AI agent or system. And inside that, you will have an LLM and an orchestrator. It will be up to the orchestrator to choose the right tools to use on the MCP server configured, and it will do that through an MCP client, which will do the discovery of all of the capabilities provided by the server, and it will take care of invoking the actual tool you are looking for, or to query the resources, or to discover the prompts available. On the wire, at the wire level, we have the standard I/O protocol if you're running the MCP locally, or you can have the streamable HTTP if you are using a remote MCP server. But on the wire, there is a JSON RPC 2.0 message schema. And from a security perspective, which is the actual topic of today's demo, we can have anonymous consumption, which is not that cool because it is not secure, or we can have an API key, or even better, we can have an open authorization in place so that we can use access tokens to access and authorize the access to the target MCP server tools. So when it comes to declarative agents to extend Microsoft 365 Copilot with MCP servers and with security, full security in place, what happens from an architectural perspective is that let's imagine we have an end user sending a prompt to the Microsoft 365 Copilot bit chat. In there, we have the MCP client. The orchestrator will select the tool to use for a specific target MCP server that we want to rely on. And if there is security in place, through the token services of the Copilot runtime, we will issue a request to get a token to consume that specific target MCP server. So the engine of Copilot will fetch the configuration of the authentication and authorization, will make a request for a token on the target identity provider, which is protecting the MCP server we are consuming, and we will get back an access token. That access token will be stored by the token services so that we can reuse it multiple times, and we will provide it to the MCP client, which will be able to issue a request to the target MCP server, providing in the headers the bearer token, the access token, to access securely the content. The MCP server will reply back to the orchestrator and to the Copilot engine, and in there, then the execution of the request will provide an actual response to the user based on the content we've got from the MCP server. So this is the high-level picture of how it works under the cover. Now, let's move to the demo environment and see how we can do that in practice using and creating a declarative agent and an MCP server secure with open authorization. So first of all, I will start showing you the actual MCP server. So this is a server that I'm going to show you, which comes from a demo that we have on the Copilot Developer Camp, actually in Lab 10 of the Copilot Developer Camp. And this is a lab that my colleague Rabia created for all of us. So here you come and you can find inside the lab, at the very beginning of the lab, you can find the implementation of an MCP server which provides out-of-the-box security for you, so that you can reuse it for your lab and for your learning, but you can also learn how to create your own MCP server secured with open authorization if you like. So let me move to the source code of this server, and here we can see that we have an actual server which is configured to have a set of tools available, like, for example, tools to get the list of claims of an hypothetical insurance company, or to get information about the contractors or the inspections and the inspectors of my hypothetical insurance company. As well as we have the implementation of an open authorization layer, which will secure all of the requests targeting this MCP server. Now, starting from this MCP server, we want to make it available through to a declarative agent. So just to give you an idea, and let me switch to the browser. Here we have the information that the MCP server can provide to any consumer through open authorization discovery and through the discovery endpoint. And here you can see, let me zoom in a bit, you can see that we have the information about who the issuer is, what is the authorization endpoint, the token endpoint, and all of the information needed to securely consume with open authorization this MCP server. Moreover, whenever you want to use security in the context of the Microsoft ecosystem, you have to configure an application in Entra ID. And specifically here, I registered an application in my Entra tenant. And this application is configured, of course, to have a client ID, which will identify uniquely my application, but it is also exposing an API with a specific permission scope, which is the access as user permission scope. I configured a client secret for this application, and in the authentication settings, I configured a bunch of URLs, which I'm using also because I'm running this server locally. And so I also need to configure some return URL like the localhost, the 127.0.0.1, and many more. For example, this one to test it with a tool called MCP Inspector. So we have this application configured in Entra ID. We can use a tool called MCP Inspector to connect and to see how this MCP server behaves. So in the authentication section of the MCP Inspector, I already configured the client ID of my application and all of the settings, including the permission scope I need to consume my API, my MCP server. So by connecting to the MCP server, I can authenticate providing my identity so that I will be able to create a delegated access token for my user, and I can go to tools and list all of the tools to get, for example, the list of claims available in my insurance platform. Good. Now, that's what we can do with the MCP server. Now, let's use it from a declarative agent perspective. First of all, let me show you the actual output of a declarative agent that I already created and through which we can list all of the claims as I did with the MCP Inspector. And here you can see I can get, by providing this prompt, for example, find all claims, a list of claims registered in the system, and with the debugger information enabled in my declarative agent, I can also see that there was an action get claims which was matched by the prompt of the user, and it was selected by the orchestrator so that the orchestrator was able to execute that action, also providing information about the request here, and I can dig into it and see that I also provided an access token and so on and so forth. How can we do that? So from a developer perspective, when it comes to a declarative agent consuming an MCP server securely, this is the actual declarative agent that I created, but I want to start from scratch. So let me go to the agents toolkit. I'm going to create a new declarative agent, which will have an action of type MCP server, so that right here, I will be able to provide the URL of my MCP server. In order to do that, let me copy from a set of settings that I already have right here. So let me do that. I will target the default folder, and I will provide the name of my declarative agent, which could be demo 2026-0407 or something like that. Okay, now that I'm done with that, the Agents Toolkit is scaffolding the new solution for me, and I will be able to show you that soon I will have the MCP JSON file scaffolded into my solution. When I have this file, I can start the MCP server. And by doing so, I will need to provide a bunch of settings to securely access my target server. So I need to allow Visual Studio Code and the tooling around the Agents Toolkit to access that server. So I need to authenticate. Of course, I need to authenticate with the right credentials. Sorry about that, but we might still be okay. And then I need to fetch all of the actions from the MCP server. Now, I can target my AI plugin JSON file like usual when we use a declarative agent and we want to retrieve some actions or MCP tools. And then I can choose to use the get claims tool, for example, which is the one I showed you before. Now, I will need to let the Agent Toolkit and Visual Studio Code know what credential we need to use to securely access the target MCP server. So I will go for open authorization with static registration, or I can also choose the single sign-on. And once I'm done with that, as you can see here in the AI plugin JSON file, in the runtime, I have a set of settings about the security, and specifically I have a reference to a setting item which will let my agent know where to get the settings about the secure access to my MCP server. These settings are actually stored, and let me show you, in the developer portal of our environment. If I go under dev.teams.microsoft.com, in tools, we have the open authorization client registration. And for every declarative agent we create with security and open authorization in place, we get a new item registered with all of the settings, like, for example, the URL of the MCP server, the client ID, the secret, and all of the settings that I created before in Entra ID to secure the access to my MCP server. I get a unique ID for this specific client registration from an open authorization perspective, and this information will become the setting we use to connect our declarative agent to the actual target MCP server secured with OAuth. And that's exactly what's happening in my Claim Assistant. If we go right here, and we can see that in our environment, we have the MCP DA Auth ID for our specific MCP server, and we get the unique ID which identifies our configuration of the connection in the dev admin UI of Teams, and which matches in the configuration of my declarative agent. So by provisioning the declarative agent into your target tenant, you will be able to consume the actual MCP server. So very quickly, and before closing up, if I go to the bits chat of Microsoft 365 Copilot, and I say, for example, again, list all claims, you will be able to see that I will be prompted to connect to the target MCP server, which is actually the server that I'm running right now on my machine. I will need to do the sign in, and now I need to confirm that I want to connect to the target server. I will need to sign in to access securely my MCP server, and now I'm going to do the sign in stage. And once I'm done with the sign in, okay, we should be able to retrieve all of the claims from the server. And in fact, while the orchestrator is processing the output from the MCP server, we can already see, if I switch back to the MCP server, that here we have got a request from my user in my tenant for the get claims tool. And now the orchestrator is just processing right here the output that it has got from the MCP server. So let me switch back here just to say that here you can find some useful links, which I will copy and paste in the chat right after the end of this demo. And go to the Copilot Dev Camp, enjoy this lab and any other lab you like to learn how to create declarative agents, custom engine agents, and in general about how to extend Microsoft 365 Copilot.